Hi, and welcome to TEMEKO. In this video, we will discuss about the principle of work and energy, which is perhaps one of the most important principles in mechanics. Think once again about the case where we had a particle moving along a certain path in inertial coordinate frame. To move and stay on its path, there should be a resultant force Fr equals summation of F, which can consist of one or more forces applied on the particle. By considering the resultant tangential force component, summation of Ft equals m times At, and applying kinematic equation and integrating both sides of the equation of motion, it's possible for us to obtain the following set of equations for the kinetic energy of the particle, where T1 and T2 define the initial and final kinetic energy of the particle. Note that these terms are always positive scalar values, whereas summation of U1 to 2 term, which takes into account the work done by all the acting forces, can instead be positive or negative depending on the nature of the work. For instance, in case of a system of particles, the work could have a negative magnitude if the object, which consists of multiple particles, is not rigid, and the particles would be moving along different paths while at the same time interacting with each other. This interaction energy would then be transformed into heat or deformation energy, which could then be stored in the object. In other words, in some situations, some of the initial kinetic energy of the object would be transformed into other kinds of energy, which causes the final kinetic energy to be less than the initial kinetic energy. You can see this phenomenon happening, for instance, when the rolling wheel, which has some initial kinetic energy, loses its velocity, which is caused by the acting frictional force between the wheel and the ground, which is transforming kinetic energy into heat energy. So as you may have already figured out, the final kinetic energy of the particle is equal to the initial kinetic energy and plus or minus the work which is done on the particle by the applied resultant force, depending on if the applied force is resistive or not. This principle is useful when we need to solve the kinds of kinetic problems which include common kinematic terms, such as the displacement and velocity of the particle, and also the applied external resultant force. Most often, in these kinds of problems, it is also very useful if you would draw the free body diagram of the particle, because this usually clears out for you to see what kind of forces are doing the work in order to move the particle. There you have it. Hopefully after watching this video, you are familiar with one of the most important principles in mechanics, that is, the principle of work and energy. Thanks for watching and have a nice day.